Hello dear audience, so thank you so much for being with me in another tutorial video of deep learning. Okay, we reached to this point and the explanation of this formula. Here we have three weight vectors. When we multiply, we have three numbers corresponding to three classes. The goal was that the number W corresponding to each class should be maximum for the class to which the image belongs. Here this yi, yi is our classes. Here it is either 0 or 1 or 2, since we have just three classes and indexing starts with 0 in Python. These are the images that are now 3072 in number. There are 4 in number or 5000 in number. It doesn't really matter at this point. I have kept the numbers small for simplicity and initial learning. Not only do we want this number to be more, but we also want to have a distance between the number of this W and the numbers of W corresponding to other classes to be sure. In the discussion of support vector machine, the margin we say is exactly this. That's what the plus 1 in the formula is for. For example, if the score of the dog class is 5.1, we want W corresponding to the cat class to be greater than 6.1. This is because we want our data to be more robust in the error vector. That is, if there was some noise in the data, the result would still be correct. Wi is the right class. J, that one is class other than the correct class. Wi is the correct class and J as the other classes. For example, if we have a cat class 0 here, in the first photo we are talking about yi is 0 and yj can be 1 or 2. We want the right class score to be higher than others. Syi is the correct class score. Sj is the score of any class other than the correct class. If this Syi is greater than Sj, we do not consider any error. But if it is less, we consider it an error as much as it is less. Here, for example, this 5.1 is greater than this 3.2. How much this greater is? 1.9. So the negative form of the number 1.9 is the error here. That means this minus 1.9 can be an error, because the points of the cat class were supposed to be higher than the dog class. Now there is nothing more, nothing new, less than 1.9. So we consider 1.9 as an error. We consider the same work for the other class, and now we add this 1 for error. Actually, the cat class score should be more than 6.1, but now that is 2.9 less than that. So this is a 2.9 error. The W matrix works well for the second data and has no lines. We do the same for the second and the third data. Now we need to take the average to see how much error is for this training set. Finally, the lower this number is, the better it is. We are looking for W for which this loss is less. With this cost function, we can not only understand which W was good and which was bad, rather we understand how good or bad it is. So the loss function should be minimum. If we consider the correct class in these calculations, the error number increases by 1 unit, but the answer will change. Then you can consider the class itself. Or for example, the average can be used instead of the sum in the formula of the cost function. There is no difference. Question: what is the minimum and maximum value of this cost function? The lowest value is 0 and the highest value is infinity. We may not necessarily get 0 itself. We want to get the optimal value. Well, this function has an error that we can fix. Let's explain the error. Suppose we find a W that make the error 0. Now, is this W unique? No. If we multiply this W by 2, the loss is 0 in W2 as well. That is, it is not unique. We definitely distinguish between these W's. Among these W, we prefer the one that is the smallest. In fact, its size is smaller. Its norm is smaller. This concept is called regularization. We not only want to minimize this formula, the solution is to adjust the weights. This formula is the average error in different data. But we want to add one more sentence. This sentence has a coefficient, but this aside for now. RW is a function of W itself. That means it has nothing to do with x's anymore. This function usually has several states. For example, we can raise each element of matrix W to the power of 2 and add them together. To minimum, the numbers corresponding to W must be small. To minimize, actually, to have the minimum. With this work, the classification of new data is also improved. The first part of this formula classifies the training data well. The second part is W, which also classifies the new data well. We want to find a balance between the two. We are looking for W that will lead us to both goals. Now, which of these goals is more important to us? We can determine with this adjustment factor, actually a regularization factor, this coefficient can be from 0 to infinity. If it is 0, it is useless. That is, our W works well on training data, but it performs poorly on new data. This lambda can also be a hyperparameter. The parameters are W's and B's. Anything other than these is a hyperparameter. The art of someone who works in this field is to adjust these hyperparameters, otherwise the rest are available as ready-made packages. Thank you so much for being with me in another tutorial videos of deep learning. In the next video I will continue the concepts as well.